solved to sum with the naive approach. So right now we're gonna do to sum semi-optimal. We're gonna have, of course, our input array, and we're gonna have our target. So the semi-optimal approach is the following. We have to do the following. First, we gotta sort the array. Then we're gonna have 2 pointers at the beginning and end of the array. If the value which gets depicted from the sum of the 2 pointers is equal to target, we are going to return the indices which the 2 pointers point to. Otherwise, if the target is greater than the sum of the values which are at the 2 pointers, we're going to decrement the right pointer. And if the target is smaller than the sum of the two values, we're going to increment the left pointer, because from the left going to the right, we increase the values, and from the right going to the left, or maybe this is the left for you guys, from the right going to the left, we decrease the values, because that's because the array is sorted. So first what we're gonna do is sort the array like this. And always, guys, it's best to use built-in functions when you can, because writing your own algorithms from scratch is usually more complicated and it's gonna take you more time. And usually in a contest or in an interview, you don't have that much time, so you gotta make the best with your time. You gotta make the best with your time. So yeah. Okay, first we sort the array. Then we have a pointer which is left equals to 0, and right which is equal to the size of the array minus 1. So the last index. Now, while left is less than equal to right, if actually this is not an int, it's a vector. We're gonna return an array with two values in it. So if array of left plus array of right is equal to the target, we are just gonna return the. And now, I might be wrong on this approach. I am not completely sure this is how you do it. I have pulled up an article right here of a solution. So we're gonna go through the article as well. But first, we're gonna try to solve it by ourselves, and then we're gonna go through the article explaining the problem. So right here, we're gonna return left and right, which are the indices. Else, if r of left plus r of right is greater than target, so this means it's greater than target. So what we have to do is we have to decrement right. Minus. And else we just have to increment left. And if we don't find anything, we're just gonna return -1 and -1, because we haven't found the indices which add up to target. Okay, so the input array is this. So we're gonna see out, okay, no, actually vector of int is gonna be this, and the target is 9, right? Yeah, the target is 9. So right now we're gonna say for int index in to some semi-optimal of r and target, we are going to cout index with a space, and let's see if this gives us the correct output. Okay, we wrote an if here accidentally. Okay, I was not declaring this scope. Okay, I misspelled target. Okay, we get 0 and 1. Okay, let's try something else. Let's try what is 18? So we should get to 1 and 2. Should get 1 and 2. Perfect. Let's try 17. We should get 0, 1, 2, 3, 0 and 3. 0 and 3. Okay. So let's see. Bool is anagram string A string B of char mem A and of, we're gonna say, so let's see. Bool is anagram string A string B. We're gonna say map of char int mem A and then map of char int mb. Then for char c in A, we're gonna do ma of c plus plus. Then for char b, for char c and b, we're gonna do mb plus plus. So if m of a dot size, we can do that, right? Suppose put map size. Yeah, okay. So it does not equal m of b dot size. This is obviously not going to be anagrams since they don't have the same amount of letters. So, and otherwise for auto, so p m of a m of a p m of a. Okay, so we got these. We got the maps. If p dot first a for auto p p1 of b, if p dot first does not equal, if p dot, okay, how do you, okay, we have two maps. Okay, I think we can just, can we just for char c and a, if m of a of c does not equal m of b of c, return false. Else we're going to return true. Okay, this should work because we're going through the characters and we have the characters in the maps. So we have In M of A, we have each character from the string A counted with a count. And then in M of B, we have each character in string B with a count as well. And so we iterate through A, and if the count uh, for M of A is not the same for M of B, we return false. So let's see if this works. A equals silent and string B equals listen. Okay, this should give true. So is anagram A and B, and this should give us 1. Okay, we get 1. Now let's see. Let's say we have 2 n's, 0. Let's say we have a t in here. Try to solve this with sorting as well, and then I'm gonna call it a stream after that because we've already been streaming kind of for 1 hour. So like, I'm not good at study, I haven't got good marks, so I can't make a good college with CS. Which type of questions? He is asking any DSA question. Yeah, I'm asking if they asked you any DSA questions, and if yes, how difficult were they? I mean, you don't need. It's okay, bro. You don't need to be in a good college in order to land like a good position, though. You just need to be good at coding. So we're gonna have string A and string B. Then we're gonna sort A dot begin, B dot A dot end, sort B dot begin, B dot end. So if A dot length does not equal B dot length, we're gonna return false. Otherwise, we're going to for int I get 0, I less than A dot length, I plus plus. If A of I does not equal B of I, we are going to return false, and then we're going to return true here. Okay, so let's try is anagram 2. So this should give false. Okay, gives false. How hard was DSA question? Yeah. Was it like a lead code easy? Was it a lead code medium? Was it a lead code hard? Okay, let's try other test cases. A gentleman. So guys, this solution it doesn't use any extra space, but it is slower when it comes to time complexity because we are sorting the strings, and basically that is gonna take all of n log n. So this is a little slower in space complexity wise. No, not space complexity, time complexity. a gentleman, elegant man, elegant man.